Hi, we're going to go over the Inference with Proportions review. It's kind of lengthy, so bear with me. You do have the printed out or the PDF of this answer key next to this video. So you could just look at that if you wanted to instead of listening to all of this. But here you'll have the explanation. Okay? On this problem here, you can see that we had our conditions. It asked which of these conditions are satisfied. Random is satisfied. It stated it right here. Okay. The large enough was not satisfied. This quote unquote normal. That's what we're doing with our large enough, is to see if it was large enough to give us sampling distribution that was approximately normal. Because look, when we did our n times p, that violated the large enough for proportions. It was not greater than or equal to 10. Okay, so that caused our problem. The 10% condition, yes, n has to be less than 10%, and since we were told there were 1,500 adults, it was. So 1 and 3 are good. The large enough was not met. All right, number 2. This one is about interpretation of confidence level. Okay, this is going to be very important, that we keep these straight. It did not say interpret the interval. So the fact that we have this information about 38 to 42% that's the interval. Confidence level is not an interpretation of that interval. So because of that, I can go here and automatically knock off these answer choices that have the interval in it. Okay? So I'm now down to just C and E. All right? And so remember that with confidence level, remember all of those intervals. We're talking about how many, and what size interval, how many contain the true P. And so about 98% of all 98% confidence intervals are going to contain that true proportion of whatever it's talking about here. And so that ends up being C. Okay, 98% of the intervals of this type, the 98% intervals will contain the true P. Here it says 98% chance of reader. I don't even know what that's going for. That one's just totally off the mark. Okay, now number 3 is doing the difference in two proportions interval by hand in formula. So you couldn't just plug it into your calculator and get an answer. They want to see that you can use the formula and know how to. So let's look down here at the bottom. I wrote the formula down here. And so that formula, it's about the difference between two proportions. So see, this statistic right here is that difference between those two formulas, plus or minus your critical value there. And your critical value will be for 90% confidence, so inverse norm of 0.05. And then this is that standard deviation for p hat, so standard error. Now this formula, see, it's actually combining the variances and then taking the square root of that. So that right there, that actually is on the formula chart. Okay, so that is those ones. You can see we're taking all the P1s plus all the P2s, and then we're square rooting those. So that is why C was the answer. That one had all the 3 correct components, and I marked out the parts that were not correct on the others. All right, number 4 is saying, hey, we have a original interval made with 95% confidence, but the new one is 98% confidence. So what's going to happen? What's the result to our interval as our confidence level is getting higher? So I want you to remember our picture over here. We've got your 95% confidence versus your 98% confidence. So that higher confidence makes it wider interval. And so that knocks off C, D, and E. Okay, but would a wider interval be more precise or less precise? It would be less precise. All right, now, number 5, I believe that I actually went in, okay, so this problem, I actually had to go and run the test. Okay, so they were seeing if, P1 is going to be our proportion with the pacemakers who snore, and P2 they defined as the proportion of the patients without a pacemaker who snore. Okay, so I have those two different things there. So based on thinking that the ones with the pacemaker snore less, so I'm kind of just thinking through my whole test process. So I can see here that I do agree with this, that they're thinking that HO is, those two have the same snore rate. Alternatively, the pacemaker group has a lower snoring rate. Okay? But we are wanting to know which one is not a correct statement. Okay, so this one is a correct statement. So that's out. All right. So I went into my calculator and actually ran this test. So I ran this two proportion test. I got a p-value of 0.118. So then I'm thinking through, okay, how does this work then? So I came down here and I wrote out, before I even really looked at the answer choices, I looked at these. So since that p-value is 0.118, it's greater than alpha, I'm going to fail to reject because that p-value is not low. So I do not have evidence that that is less. Okay. So I know going into, before I read all the problems, no evidence that the pacemaker makes a lower snore rate. Okay, let's look at B. B says they have this interval here. And look at that interval. That interval, what is interesting when we have a difference between two items, that interval contains 0. And we know if it includes 0, then there's not a significant difference. There could be 0 difference between them. So that's true because I failed to reject. I don't have evidence of HA. No evidence of a difference. Okay, C is the 95% confidence interval. It does contain 0. That is true. And so there's no significant difference. So that's true. Basically, that's just another statement of B, not quite as specific, not giving the interval. All right, let's come back to D real quick. But E says if 98% were used instead of 95. So let's think about that. 98 is going to be wider than your 95% interval. Okay, so a wider interval, if you're thinking about this interval they made up here, 98 would be even wider. So it would still include 0. So you're going to still have a situation where 0 is still in there. So this is going to also be true. Let's look at D then. At the 10% level, we would reject the null hypothesis. So 10%, let's see. Why do I know I'm going to still fail to reject? Oh, I know why. Okay, yeah. Because, okay, if that's saying, that's alpha, okay? I got a p-value. My p-value was 0.118, and that's still greater than an alpha of 0.10 as well. Okay, so I would still fail to reject. All right, so that's a false statement, and that's what they wanted. Therefore, D is the answer. All righty then. Now, 6 is going to be one where we might pull up the calculator real quick. In fact, let me get that going here. So when we do that, let's see, I'll pull that up while we're working. So this is the one where they give us a specific margin of error they want us to have, the confidence level, that's going to give us our critical value, and they want to know what size sample. So here we go. So that is what the times when you have to know to start right here. So your job as a statistician or the math student was to know that we had to start here. Do you remember on confidence intervals, that's the statistic plus or minus your margin of error. And that margin of error is this part here. Okay? So that's the margin of error. So that's why I set up that equation. Now, I fill in everything. I should be able to fill in all of the numbers except for n, and then I can mathematically solve for that. So here we go. Margin of error. They told me they wanted it to be 0.04, right there. Critical value. You need to find the critical value. While you may use the confidence level, we want to be 96% confident. Confidence level is what's in the middle. You inverse norm of one tail. Inverse norm, that 0.02 gives you 2.05. So there is our critical value right here. Now, for this p hat, remember, the best it can be is if you use true p. If you don't have that, you can just use p hat. The worst case scenario is those don't jive. Please don't cry, just use 0.5. So, there you go. That's why I put 0.5 in there. Now, if I was to pull up my calculator and take a look at what we're doing here, okay, then what I'm going to do is take this 0.04 and divide by the 2.05 first. So my 0.04 divided by the 2.05. All right. So then after I have that, then I address this squaring, and I'm going to square both sides to get rid of that square root. So I'm just going to hit squared, and it's going to square that previous answer. And see, this is a really small number. I don't want to have to mess with that number and retype it or anything. So what happens is, and this is typically the most common, the part where the mistake happens, you actually want to take this product right here, this 0.25 times 0.25, and divide it by that result you have over here on the left. Now, I've gone into this earlier in the year, so I'm not going into it anymore. So I'm sorry if that's causing you problems. If you have an issue with that, I could just talk to you about that separately. But I'm going to do second previous answer, okay? And then there we have. So that's the minimum sample size I need. So 656 isn't enough because I have to have 2/3 of another one. So therefore, I need to have that sample size of 657 or larger. Okay, and so then that's how we come up with the answer for this problem of D, 660. All right. I may split this into 2 videos. I don't know. It's getting pretty lengthy. Number 7, here we have question asking what would make the confidence interval narrower? Okay. So sample size. Okay. Bigger sample. So I made notes on here. Bigger sample size makes the standard deviation smaller. So then that would make the narrower interval. Okay. So that's a bigger one. So when it says here do a smaller sample size, that's wrong. That would make it wider. Okay, so that would do the opposite effect. Now, T procedures are more varied. So the T's are more varied, so B is out. C has the higher confidence level. So that's like going from 95 to 98. That makes it wider. And the opposite of that is E, the lower confidence level, like going from 95 to 90. That does make it narrower. D is wrong because the population size doesn't matter. Whenever we talk about that sampling distribution, it's all about what size sample was taken. So, E. 8 is very similar to a problem I went over earlier with you about the 2 proportion interval. There was the statistic, the difference in the 2 proportions, plus or minus the critical value, and then you had this thing, on the formula chart that standard deviation for those two proportions. Okay? My critical value was based off of 95% in the middle, so inverse norm of 1/tail. That's how I got 1.96. Okay? A was the answer there. All right. 9, again, was an interpretation of confidence level, not confidence interval. So, all these answer choices have the interval in them, they're out. Okay? Done. Done. Done here. Okay, so I'm left 2 answer choices, C and E. So let's see what's going on here. Approximately, remember, according to our Smelly Cat song, how many, and what size interval, how many contain the true P? So here, approximately 95% of the random samples of that same size. So here they're going to include the proportion of all adults living in the United States. E says, include the proportion of all adults in the sample. And that's where it went wrong, because that's not the true P. That's a P hat. Okay, so it's C. E was contained the P hat. All right, number 10, we have got this situation where, so if you watched my previous video about the warm-up for the naming the tester interval, I talked about this problem in it. Here we have a situation where they have this sample of 100 teenagers, okay? And they got 2 pieces of data from those teenagers. Now, you might can do that if you have means and you have quantities and you can compute the difference between the 2 students' amounts and have paired data. You cannot have paired data with proportions. So what happens is you would be getting the proportion of the 100 that are on Facebook and the proportion of the same 100 that are using Snapchat. That's the problem, because we would not be able to say that the 2 groups are independent. The 2 groups are in fact not independent of each other. Okay? They had 2 separate sets of 100 teenagers. Fine, that'd be good. They are not independent of each other. And so, the reason that matters is because if they're the same ones, if the fact that they are like on Facebook, does that make them more or less likely to be doing Snapchat? Maybe more likely because they're into social media. Maybe less likely because they prefer Facebook over Snapchat. I don't know. Or the opposite. Probably more the opposite, because only old people are on Facebook, right? Okay. So that's why it was C. Number 11. This was a situation where we had this 2-tailed test. We were asking which is a correct conclusion. Okay. So when we're asking for the correct conclusion on that, let's see here. If I can pause this, I don't know. All right, we're just going to keep going. So here we go. All right, so we've got this situation. We got the 2-tailed test, the difference between them. Let's see. I think that, which is a correct conclusion. So I have, there we go. P-value, 0.0015. Okay, so if I have a p-value of 0.0015, then you're going to reject the null hypothesis, okay? So I'm going to reject the null, so therefore I do have evidence that they're not equal to each other. Jackson, stop. Okay, so I have evidence that they're not equal. All right, now we just go through these things. Not one, that's false because it was a 2-tailed test. B, they were 2 different independent. They weren't small enough. They weren't too small. Okay, they were okay. Both of the successes and failures for the groups were greater than or equal to 10. Okay, so they had at least 10 successes and failures for both groups, and so that's what we're looking for um, to be large enough. All right. C, the p-value wasn't large. D, the p-value was small, but since it was small, I do have evidence of a significant difference. D says no evidence, so it's E. All right, then we've got our next one here, number 12. Okay, we've done one very much like this earlier. Okay, so we have that situation where we are given that margin of error. We want to have this much size margin of error, being 94% confident. Okay, and so remember, here was the key to that. There was the key, knowing that margin of error formula. And so we have no p hat, so we ended up having to use 0.5. And so here is plugging in the numbers, and then I went through the calculator and I got 180.33, so our sample size need to be at least 181. Okay. Alrighty then. Number 13. All right, which of these statements is true? So one says if we're going to be rejecting at the 10% level, that means so I actually I think I'm going to be changing my answer here. Okay. Let's see here. If there is sufficient evidence to reject the null hypothesis at 10%, then we're going to reject at the 5%. Okay, that's no. Because, see, if I had a piece of data right there, I could be in the rejection region for 10%, but not in the rejection region for the 5%. So, my bad. That is a no-go. That one is not true. 2 is also not true. So I've got to change my answer here. Whether we use a one or two-sided test is decided after the data are gathered. No, we don't. We decide if it's one-sided or two-sided based on what we're wondering. What's the claim and what are we hypothesizing about? Okay. 3, if a hypothesis test is conducted at the 1%, then there's a 1% chance of rejecting the null hypothesis. So I had to think about this one, and here's what I came up with. If the hypothesis tests at a 1% level, okay? So then here, say this is your null hypothesis here, okay? Then here's your alpha. There's your size of your rejection region, 1%. Well, what happens if the data is actually located over here where the alternative is true? Do you see all of this data? There's all of those samples that will lead you to reject the null hypothesis. So there's a much higher chance than 1% chance of rejecting the null hypothesis. Okay. 3 is true only if, the HO is true. You don't have HA at all. Okay. So, in fact, apparently all 3 of those are wrong. So none of these gives the correct set of true statements. Okay, none of the above. All right, so there's that. 14, here we have got this, let's see here. Okay, so I actually went and filled in this information and I ran a 1 proportion Z test with the null hypothesis of 0.23. Okay, so I went and actually ran the test in my calculator, and the p-value I got was 0.1314. Okay, but don't jump to that conclusion that B is the answer, because if you have a p-value of 0.1314, that is greater than alpha, and so you would fail to reject HO. So let's read the question. Is this strong evidence to claim that the new medication reduces the mortality rate? Do we have evidence of HA? And we do not. We do not. We are holding the HO. We did not have enough evidence to reject it and conclude HA. So, see, that's why it has to be C or D. And so A and B are out. So now the p-value is not this, so that's false. It is above 0.10. Okay, so it was a p-value that was greater than 0.10. All right, we're going to do one more here, and then once we get to number 16, I'm going to start that on a separate video. So here we go with this number 15. So I have the information. It asked if we have 2/3. That's our claim, 2/3 of water on this globe, okay? But we get this sample, that p hat. So I went into my calculator and actually ran this 1 proportion z test. And when I did that, I got this p-value of 0.081. So they say, okay, what does that mean then in reference to this alpha of 0.05? So that p-value is greater than alpha, so that HO does not go. I'm going to fail to reject the null hypothesis, and I do not have evidence of HA, okay, because my HO is that it's 2/3, my HA is greater. So that's why it is D. I do not see these ones that say yes are out. I do not have convincing statistical evidence that more than 2/3 of the earth is water. All right, so I'm going to start another video with that starting at number 16, and we'll just finish that out here in a minute.